Good afternoon all. Now this is what I call electronics. Circuit boards all connected together with wires, power supply cables all coming from my little power supply distributor here. Phono cables linking all the audio parts of the circuit together. Lots of knobs to twiddle, that sort of thing. So this little board on the right is an LED bar graph, 10 LEDs. This one in the middle is a little preamplifier, and I've got some music going into there. Just have a quick blast. Like that. And on the left here we've got a sort of sound synthesis board, this is the circuit diagram of, there's a noise generator here. It's a couple of CMOS chips, generates pseudo-random numbers which sound like noise. That's the noise generator. And then there are two oscillators here. They're sort of triangle wave comparator, which turns them into a square wave. So we have 3 controls per oscillator. Let's have a little play with that. I'll raise the level of one of the oscillators. Sounds like that. Raise the level of the other oscillator. Same frequency. Slightly off, so it sounds like that. Let's change the relative frequencies. So those are a fifth apart. And now they're an octave apart. And the shape control just gives a little bit of phasing sound. I quite like the notes being a fourth apart. That's a fifth. That's a fourth. That sounds pretty good. And if we bring the noise back in as well, yeah, quite a fun thing this. You can play with that quite a lot. So here's the thing, the noise generator is fed into this little mixer. It's a 741 op amp. It's actually right there. And so are the 2 oscillators. So we can mix these 3 sounds together in this little mixer. Also, we can mix in music from an external preamplifier, which I showed you, which is this one. So we have 4 sources into this 741 op amp mixer, but then what happens? We rectify all of these audio sources. Rectify with this 4 diode precision rectifier. It uses op amps to eliminate the voltage drops of the diodes, but essentially this rectifies the audio. Well, that's weird. Why would you rectify audio? Because it's going to sound, well, pretty horrible, isn't it? Fact is, I don't really know what rectified audio sounds like. So what I was thinking of doing today was building this part of the circuitry. It's not that hard. It's an op amp, it's a dual op amp, a bunch of resistors and 4 diodes, and then we'll connect the audio amplifier to this point here. Currently it's connected with this blue wire to the back end of this mixer op amp, but let's connect it to there after I've built this and see what rectified audio sounds like. What do you think? So I'm going to have to do a few things. I'll turn off the battery pack. That turns off the power supply to all of this. 5 volts directly from the batteries, and then this little board here generates plus and minus 12 volts. I've got to disconnect some of these connectors. That's the final output which goes to the amplifier. This one just connects the output of this preamp where the music is into the, what this is called, the excitation board, the board which has the noise and the oscillator sources. Take off the power to this board which is on a JST, and that liberates this board so that I can fit this component here, which is a dual op amp, and you can see the diodes around it which make up this precision rectifier, and then on the output of that we'll see what it sounds like. let's get some parts. So first things first, I need my dual op amp, which is an LM1458. Let's just bend the pins in so that it fits in the socket. I've made two of these little turned pin socket arrays, so I'll stick those on there. I don't really want to clear all this stuff off my mat, so I'm going to try and solder it with everything in place. It's going to be a little bit tricky. So that fits in there. Let's get the soldering iron warmed up. So with my finger on the back of the board, this is quite a heavy board with all these potentiometers on it, so its own weight is holding down, or holding the board down on this chip. So when that gets up to temperature, clean that off and solder some of these pins in, trying to keep the chip flat in its socket. Slightly tricky, this soldering the thing in mid-air, and my solder's getting rather short, and that's getting a bit hot, so let's get some more solder. Now these resistors are mostly all the same, 4K7, apart from this one, R14, which on my board is R28 because I'm working to a different schematic. I redrew it. That's 1 megohm, so let's solder that one in. Wildly different light levels today. It's one of those days where the sun keeps going in and then coming out again, but I can't be putting the blind up and down constantly for every shot, so I'm just going to have to go with it. So everything else around this op amp is 4K7, and I've treated myself to a box of 1,000 4K7 resistors. So quantity 1,000, 1%. They're 0.6 watt S, which is small. They're a sort of light blue colour. The code is 47 black brown, so that's 4700. Yeah, 4K7. Let's get a few of these in. Yeah, 1,000 resistors, and these are these nice quality copper leg, nice thick legs on these. So let's cut a bunch of those off. And I treated myself to some other values as well. 10K, 47K, and 1K. And I'll probably follow this up with another order of, I don't know, 470K, 1 meg possibly, 470 ohms. These resistors are totally dreamy, thick copper legs. None of this spindly thin steel rubbish that you get when you buy them on eBay. I just felt I deserved decent resistors. About £8 or £9 for a pack of 1,000, so it's not cheap buying up large stocks of common values, but I think it's got to be done. So those 4 resistors, then 4 diodes. Let's turn this over and get those all soldered in. Yeah, quite looking forward to hearing what rectified audio sounds like. If you imagine a sine wave, and then you take the bottom curved part and flip it to the top, then of course you reshift the 0 level, because a DC blocking capacitor will do a level shift. You can imagine the bottom is going to sound quite sort of triangular. So I would imagine that the main effect of rectifying audio will be simply to distort it. So if you imagine a sine wave audio signal, or just a sine wave AC signal, this is the 0 point. When you rectify it, of course, you put both halves of the sine wave above the 0 line, and then if you feed that into an audio amplifier which has a DC blocking capacitor, most will, it'll kind of settle to a mid position around here. Well, the tops are sinusoidal, but the bottoms are much more sharp edged, much more triangular, and that's why you get the distortion. So why does this circuit put a precision rectifier after an audio mixer? What's the point in rectifying, where's my little bucket of cut-offs, I don't know, rectifying audio which would distort it immediately after mixing a load of audio sources together? Well, all will be revealed. So now the 4 diodes 1N4148, of course. It's really the only signal diode that anyone ever uses. Well, that's probably not quite true. So once again, why do they use a precision rectifier? Ooh, that didn't bend very well, did it? Rather than just a 4-diode bridge rectifier? Well, because with audio, you don't want a distortion at the zero crossing point. Now, if you have diodes without the op amps, you'll get a 0.6 volt drop across each diode, and that'll give you massive distortions at the zero crossing point. With a precision rectifier, the op amp takes away those 0.6 volt drops. Get these in the right way around, of course, haven't I? And you get what is, in a sense, a perfect diode, an ideal diode. So if an ideal diode takes away the zero crossing distortion, why am I saying that the rectified audio will sound distorted? Well, because it will. The purpose of this rectifier is not for audio. Once it goes past this rectifier, it's not intended to be used for audio. But I thought it'd be quite fun to listen to it and see what it sounds like. I can't quite get that one in. Let's push it in with my pen. That won't quite fit. So there are the diodes. They're all in with the 4K7 resistors and that 1 meg. Now I can pick the final output off there, R32. That's the resistor that takes it onto the next stage. So let's link that with my original blue wire into this socket. This is actually an input, but it just goes to this point on this ribbon cable connector. So I can use that as an output, put that on there, and we should be able to listen to rectified audio. Let's get the plugs and sockets back in. So this is going to the powered speaker. This is 12012 power for this board. Okay, let's switch on my power. Click from the speaker. Is my MP3 player still playing? Yes. Let's see what it sounds like. Oh, it doesn't sound like anything. What have I done wrong? Well, you can't really hear anything, and I suspect part of the problem is that this point after the diode doesn't really have any ground reference because I've not fitted these components. If I fitted these two resistors, it would probably work. So I think what I'm going to do is listen to it behind this diode, because then we've got the low impedance output of this op amp. Let's try that. So that is here. Yeah. And that just sounds horribly distorted. Now if I go back a bit further, that is also hideously distorted. Now what am I looking at here? Well, now I'm just going to muck about and pick off sounds off various points, like there. I think the MP3 player has stopped momentarily. Oh, there it goes. Yeah, also distorted. What about this part? Distorted and very loud. What about here? That's probably a power supply point. How about here? Well, there are no two ways about it. It's hideously distorted. So, massively distorted music. Now perhaps I should explain why they've chosen to take a music input, which is actually here, or the input from two oscillators or a noise source, and distort it. Perhaps we'll turn this off while I speak. Well, the fact is that after the rectifier, this isn't intended to be an audio signal. What this does is it rectifies the AC signal. Audio is of course AC, and then it puts it through this, which is a low pass filter. So it's the equivalent of rectification and smoothing, so that at this point you have the average level of the audio, because the next thing it does is control a voltage controlled amplifier, and it needs to know how loud is this sound being generated in this section of the board. So rectification and low pass filtering gives you a DC level, all above 0 of course, that corresponds to the volume level of all of this audio, including the music input. That's why they rectify the audio. You're not meant to listen to this point here. Now if you apply that distortion to the noise sound, well, you barely notice it because noise is pretty distorted anyway, or it's a random sound. Even the tone generators. It's not massively, they do sound distorted, mix in the noise. It's not terribly obvious, but it certainly is when you put music through it. And because I feel that you'd like to hear the non-distorted audio compared with the distorted, I've added this extra shot. So here's the non-distorted. Quite loud, but not distorted. And here's some distorted. Clearly distorted. Back to the non-distorted. Incidentally, this control is a tone control. Take the treble away, take the bass away. So I'll put that in the middle. Non-distorted. Distorted. Another track now, distorted. Non-distorted. That actually sounds quite good. Back to the distorted. And that's a comparison. So that's what rectified audio sounds like. Terrible! Cheerio.